Now, since we have through with the basics of surfacing and we have understood like how surfacing works, there are some commands which are used rarely. So we will be looking at those commands in this exercise. So first one was 3D offset. So this is 3D offset. We will learn how these commands work. Okay, we'll create a new geometrical set in which we are going to do whatever we are creating. And now we just simply create a curve. We'll create it on this plane. We'll start with the point. So this is a point, and then we have this curve with this direction. Okay, now see how a 3D offset works. So it is along with the parallel curve. You can find it here in the wireframe palette. We have this curve, and then we have to provide a pulling direction. So this curve, it will actually move normal to the pulling direction. So suppose if we give z as a pulling direction, we can give an offset to this curve in this direction. And in case we want to provide a pulling direction in this way, which is the x1, then we can actually move it in z direction. So it works like that. So in y direction, we actually cannot offset it because it is a linear curve. Let's try if we give a bigger value, we might see some results. But because it is linear in that direction, we really won't be able to see any results. Let's just try for the sake. Okay, so this is a curve. We will try this. Sorry. Uh, this is the curve, and we will try y direction. Surprisingly, yeah, it is not giving any option. Say I give it 1000. No, still no chance. Okay, so it won't work. Along the edge, it will work only perpendicular to edge. And suppose if we have a circular profile, say we have a circle which need a center and base, a support. We have a circle of 20 millimeter radius. Now here what this command will do, we select this curve and we use a pulling direction y, and now we can offset, increase and decrease the size of this curve. Okay, so this is how offset works. And yeah, again this circle, we are using y direction and we are seeing the offset normal to y. We can't really do any offset in z or x direction because the same reason, it is a linear direction, so we really can't see that. Okay, so this is this command. Now after this command we will look at this one. We will look at these four commands. So first one, it is a bump. So for this command to work, we need a element to deform. We need a limiting element. We need a center of that deformation, and then we need the direction to it. Okay, let's try some surface. Say I create this flange and I do a extrude in this direction. Click OK, and I create a point. I have this point here, and I put a circle. This point with this as a support. So this is our circle. Okay. Now let's try if this command works. So element to deform, we want to deform this element. Limiting curve, this will behave as a limiting curve. We need to, whenever it says limiting curve, we need to make sure that the curve is in contact the whole curve should be in contact with that surface. So that is how it is going to work. Next is deformation center, which is here, and then we have deformation direction. So say, because this is a flat surface in x and y, we give a deformation direction in z, and yep, it is z, and say we give 20 millimeters. So this is how it creates a deformation. We can increase this deformation, we can also decrease it on the other side, and we can also change the curvature. So from curvature, which we means the curvature at the center, so we can increase decrease the tension. You can see uh, this is when we are decreasing the tension, sorry, this is when we are yeah, increasing the tension, and this is when we are decreasing the tension. Next we have these options of point, tangent, and curvature. So point is like, it will give a simple dome kind of profile, and I really don't think, yeah, it is still having some effect. So this is what point profile looks like. Then we have tangent, this is tangent profile, and we have curvature. So because of the uniqueness this command, this it is hardly used. Okay, so this is deformation command. Next we can look at another command, which is wrap curve command. Okay, so what we will do is, yeah, we have this surface, we have this curve. Let's hide this circle and we hide this point. Let's see what are the things that we need. So we need some reference, we need some target. So here it could behave as our reference. Then we need something, some curve for our target. And element to deform, we can choose this. Yes, it is considering this as an element to deform. And let's see later what are these options. Okay, so okay, we have this surface, we have this edge. Now we will create one more curve. Let's create a plane. I'll create a plane little away from this thing. I have created it at -120, that is fine. Now we create a sketch on this plane. Okay, and say we give some curvy profile. Let's make it a little. Okay, now we exit it. So what we are trying to do is, here we will try to wrap this surface uh, in this way. So let's try it out. We are going to wrap it with this curve. So this is what we want to wrap. This is our reference here, and that is a target. Let's see what will happen. Okay, you can see that now this surface, it is following the profile of that curve. So this is how wrap surface works. After that, uh, we have one more, which is wrap surface. So yeah, okay, earlier it was wrap curve. Now we have wrap surface. So we already have this surface here, but uh, okay, let's try if we can do it with this surface. So let's look at the requirements. We need an element to deform, which could be this one. Then it is saying they need a reference surface, then they need a target surface. Okay, they need a target surface in this case. Earlier they were looking at a reference curve and a a reference curve and a target curve, but here it is surfaces. And we have here options 3D, normal, with direction. Okay, let's see how it works. So we have this surface and we just offset it, say by 10 millimeters. And we have one more surface, say here. Mm, we click OK, and we try using this command. This is the elemental deform. Reference surface is this one, and we can have our target surface as this one. Let's see. Okay, it is like it is creating a copy of it. If I select normal, it's the same result. Then with direction, it is asking for direction. Say I give this direction. Okay, so it is like this. Now if I change the direction, say this one, there are no results. Then here, no, there are no results. Okay, so let's understand this command a little in a better way. We'll try to understand both of these commands in a better way. So we can create some say we will create some linear surface. Say uh, let's create a beam. Okay, I'm creating this. Sorry, I'm selecting this plane, and I need a projection point which will be this one. I don't know why. Okay, it is creating inside that one. We'll have a new geometrical set. So earlier it was creating the sketch inside this geometrical set, and I was not able to see the horizontal and vertical coordinates. So I select here, next projection point, I select here. Okay, and now we create a simple beam. Say I create this, and I pad it. So I have this profile with me, and now I will have a reference surface, say 50 millimeters away. Okay, it is offsetting the entire thing. So I just want one surface. So I offset, I right click, and I create extract this surface. Click OK. Now you can see it is showing here it is an extract. Now here I give a value, say 50, preview. I want it on the outside. Okay, so this is our surface that we want to deform, and then let's create a wavy something, a wavy surface. So we do a offset plane and say here minus 450, and we create a sketch. Let's reverse it, click OK, and this is our profile. We just try to make it not too curvy, like this only, it is fine. Okay, so let's try if this command works, because earlier it was a very simple example. Let's try with this one. So I select this surface, then I choose a reference curve, which could be this one, and then a target curve, this one, and this is the elementary deform. And we try to click preview. Yes, you can see. Now this is how it is deforming the surface. And it looks like uh, we can add more reference and targets. So I really don't know how it is going to work. Say I create a copy of this curve. Let's see what will happen. I use this translate feature, this along this direction. I click OK, and I translate it again. Let's create a simple profile. We delete this, and we create a copy of this sketch. I delete what is in there and I create a straight profile. So these commands, they are so rare, they are hardly used, and that is the reason, because they are complex, and that is the reason nobody uses this command. If someone uses this command, it is also for a third person to difficult to understand them. So this is what we want to work with. Now let's provide a reference. This is a reference, and say this is our target, and then we give another reference, say this our reference, and we provide another target. Yeah, we have provided two references and two targets. Let's see how it is going to behave. Okay, so this is how curve deform it behaves. Remember, we give this edge as a reference to this one, and that edge as a reference, and here is a target. So this is reference one, target one, reference two, target two. So this is how wrap curve works. And let's see how we use the same thing with the surface. So we pad them. I create a surface, say this one, click OK, and I do the same here, click OK. And now let's try this command, which is wrap surface. Element to deform is our this bar, and then we have a reference surface, which is this one, and we have a target surface that's here, and we do a preview. Okay, so it has stretched in earlier command when we were using the wrap curve. It was not stretching the profile, but here it has stretched the profile all the way to the size of this surface. Okay, we can use a normal and see preview. So here it is trying to maintain a normal profile, like what normal profile we have of this block with along this surface. It is trying to maintain the same normal profile of this block with this surface, and that is why here it has went inside one another. The one surface is inside another surface. That is what is happening here, and it is a very bad practice. It should not happen. Next is with direction. Let's say we give a direction X. It's not working. And if we give a direction, say Y, there are no results. And if we give a direction Z, okay, so it has created the same profile here. So in wrap surface, we saw that it is also stretching the whole thing. And for just to confirm, we can select this, and we select this as a reference and this as a target, and we click preview. So here you can see it is actually not stretching the object, but in earlier case it was actually stretching it. So this is how the wrap commands works. Next we have something called shape morphing. Okay, so to understand shape morphing, mm, let's use this example itself. So we hide everything else and we just keep this surface. Okay, so let's try shape morphing on this four surfaces. So let's see what are the options we have. So it is saying the element to deform, then we need reference and we need a target. Okay, and then there is a limit. Okay, so we can put a limit. Say we create an intersection. I'll create two intersection just to make it uh, what do I say, a little more exciting. So this is one intersection I have placed here, and I'll place one more intersection which will be throughout this surface, like all around the circumference. So let's give some fillets also. Okay, sorry, not this one, the second one. Okay, 5 is fine. Little increase it, 20. Okay, we have this fillets. Now we give another intersection, this and this. Click OK. Okay, so this will behave like a limiting curve, and now we need to create some target profiles. Sorry, target curves. So here it is saying reference, target, reference and target. So those are the two things we need. So let's create references on this side. I'll make use of this 3D offset, this curve, this direction, 5 millimeters. Okay, and we create. Okay, so this will become our reference, and let's create a target as well. So offset this curve, say 100. Pulling direction is this one. Okay, and we do the same here. Pulling direction is this. Instead of 100, I'll give something else. Uh, 50 and 150. Okay, so these are the things we got, and let's see how the morph works. We want to morph this element. We have a reference which is this one, and the target being this. Here we will use, we can right click. Okay, we can add this as a reference and target being this. Okay, and let's give a preview. Okay, so we can see that it has, deformed the surface, and then after that, this is fine. We have a limit element here. So let's say if I choose this curve and click preview, I don't know what happened. Let's give tangency. I'm not getting any error also. Okay, so let's do one thing. Let's reduce it to 10, and now try this surface, this edge as a reference, this as a target, and another this as a reference, this as a target. We give a preview. We got surface like this, and limiting element we give this curve. It's gone again. And what if instead of this we give this one? Okay, so limiting element, it need to be, uh, again, like last time, it should have a complete intersection with the whole curve. Only then it is going to work. But surprisingly, it was not given any error. So it was, and I'm not sure what I was doing. So this is how this deform thing it works. Sorry, morphing. And these are all deformation commands. And let's try if we change the direction, reverse. So this is another result that we can get. So I'll give a real life example, like where we can use these commands. So I'll create one geometrical set. Okay, I have it here. Now I'm going to create a sketch. Okay, and to this sketch we will create a profile, say something like this. 200 is fine, and the height, okay, it is little too big, just ignore the values. 100. Okay, now we usually have like hoses, like a kind of washing machine hose. I'll make them as a reference. And now we create a profile like this. We give some angle to it, 30, and this angle with the horizontal as 15. We bring it down slightly, and I want it to be this point, say how much is this? This is 100. Then let's make it say 30. Little more. We'll make it 50. Let's make it 100 only. Okay, so it is like this, and we can move it down. Okay, and we trim away some curves. This one and this one. And now I'm going to create a pattern. Say I'll use this translate, and in translate I say I want, okay, later we will look at the instances. Let's just create 10 instances first, duplicate, and I will select, sorry, I just need to select these two first. Select these two, translate, we keep say 10 instances, duplicate mode. This is the reference, and if we, let's see till where they are going to go. Okay, so this is only 10. I need some more, say 25, and I click here. Okay, this is fine. So I did a it is just for the sake of knowing the command. So don't do like this in an actual project, because it will become difficult to manage all these shapes. Okay, now I have this. Now what I'm going to do is I will make a circular profile with the help of revolve. I choose this, and this is the center axis, and I want it to be a complete 360. I click OK, and if I want, I can give a small radius. 10. Okay, so this is our radius. And now say we have a curve, point and direction. This is our curve. And so this curve will become a reference to this profile, and say suppose we want to put this same profile into some sort of curvature. And this we usually do when say there are some home design projects or we are doing some wiring. We have this kind of plastic covers, and we can have some wiring like this. So we can get the center profile of it, and after getting the center profile, we can actually use this command, wrap curve. This is our object that we want to wrap. This is the reference, and here is the target. We click preview. So this is how it wraps around this curve. And we have here options like none. If we do none, it is not working. It is not working. Okay, so this is how this command works. It has wrapped around this curve, and you see that the profile of these circles, it was not changing with the normal of this curve at any point. But let's see what will happen if we try to do the same using a surface, because surface will have some direction, and in curve the direction is always along the curve. So let's create a surface. I will create it in this direction. Click OK, and we create one more surface with this one in this direction. And now using this command, we can see this element. This is reference surface, this is target surface, and here we can choose 3D. Let's see what will happen with 3D. So this is 3D output, just like what it was happening earlier. Next, let's change it to normal, and we click preview, and now we can see that the profile of this uh, feature, it is, it is always normal to this curve, how it is always normal to this curve here, sorry, the surface. And we also have with direction. So here say we give this direction. It's not working. So let's say we give this one, and this is the output. So with the direction, output is very similar to 3D, but in 3D we can see that it is slightly stretched. So I go back to 3D and see the difference. So it is stretched actually. Okay, and the best result for which we can use this command is this one. Okay, so this is our reference object, and this is our result. So this is how deform commands and curve offset command work. Thank you.